Let's have a look at Edx M3 January 2011 question 6. It's on the topic of elastic potential energy and conservation of mechanical energy. Here's the question. So take a good look at it, pause the video for a while, and let's get started. The first part wants us to show that K equals 10. Let's remind ourselves we've got a ball of mass 3m and the modulus of elasticity lambda is kmg. So in green at the bottom left corner here, I've just done some working out by Pythagoras. BP is 5L over 4, and also if we call this angle theta, sine theta is 4/5 and cos theta is 3/5. We'll need that. So resolving by symmetry, we've got T there and T there, and we'll have a 3mg down there. So resolving, we've got 2t cos theta, resolving vertically, 2t cos theta equals 3mg. Putting cos theta in them, we get t, 2t times 3/5 equals 3mg, giving t equals 15mg over 6, or 5mg over 2. Yep. Now t equals lambda x also, so 5mg over 2 is lambda, which is kmg, times the extension. Now the extension is L over 4 because the natural length is L and it's now of length 5L over 4. So that's L over 4. So that's Hooke's law, T equals lambda x. And that takes us straight to, once we cancel out the mg's and move things around a bit, that takes us straight to K equals 10, which is what we want to show for 7 marks. Surprisingly high scoring. That's that part of the question done. The second part of the question brings in energy. And in the second part of the question, the ball's pulled further down, so it's now a distance 12L over 5 below C. C is here. Then it's released from rest, and we've got to find the speed of the ball as it reaches C. So in this case, you've got to think of what happens in terms of a conservation of energy equation. And I'll leave you, just pause the video and think about it for a minute. Now hopefully you've come up with something like this. Well, something like, hopefully you've come up with the elastic potential energy initially goes to kinetic energy plus gravitational potential energy as it moves from the bottom here, as it moves from here up to there. All we have to do now is put the values in. So the extension at this point at the start, just check this, is 8L over 5. So the elastic potential energy at the start, remember there's 2 strings, so it's twice lambda x squared over 2L. Let's just put that here just to remind you. That's the energy stored in an elastic string if it's stretched to an extension x. So twice 10 mg Right, I'll carefully put in all the numbers there. And a lot of things, well, the m's cancel out first of all. There's a lot of tidying up to do, obviously. We're trying to get the v. We've got the v squared term over there. I'll skip a line. You can check that you get this. V squared is 256 GL over 15 minus 72 GL over 15 which comes to 184 GL over 15. So there's V, the square root of that. Okay, and that's it. That's the end of that question. Let's just look at how the marks are allocated. And for this first part, we had, let me just see in the mark scheme here. For the first part, we had a B1 mark for sorting out the geometry and working out the length down here and the extension. We had 2 method marks and 3 accuracy marks for doing the resolving and putting together the resolving equation with Hooke's law. So I'll just call this M2. That's supposed to be a 2, something's gone peculiar with it. M2 there, and A3 for this part. Okay, the 2 method marks were one for the resolving and one for Hooke's law. And for the other part of the question, part B, we had a B1 for working out the length of the new string and from that getting the extension. And we had, again, 2 method marks and 3 accuracy marks for this. So I'll just put that down, M2, A3. Yeah, that gives a total of 6. The method marks were for correctly stating the principle of the conservation of energy, and then for putting in the right expression for elastic potential energy. And then the accuracy marks were for the right numbers in the right places, basically, and for sorting out the equation and getting V. Okay, that's it. I hope that was useful, and thanks for listening.